All right, so here we go. We are going to be looking at one more problem dealing with polynomials and roots and all that fun kind of stuff. All right, so here we go. When p of x is divided by x squared minus 3x plus 7, the quotient is blank and the remainder is unknown. However, when p of x is divided by x minus 2, the remainder is 29, and when divided by x plus 1, the remainder is negative 16. Find r of x in the form ax plus b. Okay, very well. Then let's go ahead and have a look. So we're going to say that p of x divided by x squared minus 3x plus 7 equals x squared plus x minus 1 with a remainder of this, whatever it is, over x squared plus 3x x plus 7 minus, because minus would match the other side. Okay, now what does that mean? Well, that means that p of x, if I multiply both sides by the denominator, is equal to x squared plus x minus 1 times x squared minus 3x plus 7 plus r, right? Because that one, the bottom would cancel out. Okay, so very nice, and it does have an r of x up there. Okay, so we're moving along. Now, this says when p of x is divided by x minus 2, the remainder is 29. So what does that mean? Well, according to the remainder theorem, that means that p of 2 is equal to 29. And when divided by x plus 1, the remainder is 16. So that means that p of negative 1, because this would be x minus negative 1, right, equals negative 16. So we actually have a couple of data points there that we can put in to try to find out what the remainder is then. Okay? Now, it does say that Rx is in the form ax plus b. So from there, we can just kind of put these things together and see if we can figure out what's going on. So we're going to put 2 in for x, right? So that'll be 2 squared plus 2 minus 1 times 2 squared minus 3 times 2 plus 7. And so that'll be 4 plus 2 is 6 minus 1 is 5. And then 4 minus 6 would be negative 2 plus 7 is another 5 plus Rx. So when I put 2 in, then I get 29 equals 25 plus Rx, which is in the form ax plus b. Right? The remainder will be linear because the original dividend right here was a quadratic, meaning that a quadratic could divide in, but a linear can't. That's why I got a remainder of that. So I go ahead and subtract over, and I end up with, oh, and I know what x is there. It's a times 2. So that would mean 25 over. So I'd get 4 equals 2a plus b. Well, that's pretty smooth. Let's do the same thing, except let's put in negative 1. So we're going to go negative 1 squared minus 1 minus 1. And then negative 1 squared minus 3 times negative 1 plus 7. And if I work that out, I'm going to have 1 minus 1, which is 0 minus 1 is negative 1. And then here I'll have 1 plus 3, which is 4, plus 7, which is 11. And then, of course, I got my plus ax plus b. And this will equal to p of negative 1, which was negative 16. And so I got negative 16 equals negative 11, not negative 111, just negative 11, minus a plus b. Add the 11, I get negative 5 is equal to negative a plus b. At this point, it should be fairly easy to solve for a and b, right? You can use any type of method that you want to solve two equations. I'm actually just going to take this one and subtract this one. So I'm going to take red minus blue. So 4 minus negative 5 would end up giving me 9. 2a minus negative a would give me a 3a. And of course b minus b would cancel out, which means that a is simply 3. Once I have a, I can put that in, and b is really easy to get because b will then be negative 2. And so I've managed to find a and b. Remember, the question asked for r of x, so my final answer needs to be r of x equals ax plus b. And that will be my final answer right there. Pretty cool, eh? All right, well, that one's done. Go ahead, let's do one more. That was fun.